When sampling LNG for the measurement of properties and composition, there are two imperatives to be obeyed to ensure accurate results. 1. The sample must be maintained in a subcooled condition below the bubble point until the moment of vaporization. 2. The conversion from liquid to gas, the phase change, must happen instantaneously without fractionation. This is called flash vaporization. Additionally, the sample should be extracted from the center third of the pipe as per all good sampling procedures. Maintaining the sample at a temperature below its bubble point has proven to be difficult for many years. Initially, merely vacuum-insulated pipework was used, and later some suppliers added concentric flow cooling, keeping the sample pathway and valve surrounded by LNG. Both methods require heat ingress calculations to be performed. We have used ingenuity and harnessed physics to improve and revolutionize LNG sampling. Instead of the sample exiting from the top of the pipe, as is typical for sampling, the exit route is made from a connection below the horizontal. This avoids the sample passing through and picking up heat from inside the process in the nozzle connection, where warmer LNG will accumulate due to buoyancy, or where vapor bubbles may accumulate. In such a connection, flow is stagnant and additional warming occurs, further heating the sample before it even exits the process. Connection nozzles below the horizontal will naturally fill with the denser, colder liquid. However, the connection nozzle will form a semi-stagnant flow region. The liquid within it will gain heat from its surroundings, warm up, and natural convection will initiate in the pocket. This cannot be relied upon to ensure the sample pathway is maintained in a subcooled condition. Additionally, vapor bubbles may form and rise close to where the sample enters the sample probe. To avoid this, the probe may be inserted slightly off vertical. To keep the connection pocket filled with the coldest possible liquid, a deflector plate is installed. The deflector plate is designed to continuously force cold liquid from the main flow into the process connection nozzle. This will keep the sample subcooled until it exits the process. This overcomes a problem not previously considered, an innovative and invaluable improvement. The problem now comes in keeping the sample subcooled after it exits the process. Typically, this has been attempted by using highly insulated tubing, usually vacuum insulated tubing, or exploiting sacrificial LNG in a concentric tubing arrangement, with the sacrificial LNG flow being sent to the boil-off gas header. The same principles and configurations are utilized to keep the sample isolation valve similarly cold. Such configurations are complex, relatively large, and a waste of LNG. They still are unable to maintain the necessary subcooling without large amounts of LNG being essentially wasted. To overcome these issues, we have invented an integrated valve vaporizer that connects directly to the process nozzle. This arrangement no longer needs the sample to be kept subcooled after it exits the process nozzle, as the sample directly enters a flash vaporization chamber on the process connection, with an isolation valve being incorporated at the same point. In this solution, liquid is flashed across a critical orifice that has a high temperature gradient over a confined section. Furthermore, the sample immediately impacts onto a heated valve stem tip, ensuring no possibility of retrograde condensation. Flow direction is in a vertically downward manner, another innovation, counteracting normal buoyancy distillation. Vaporizing bottom to top encourages buoyancy separation, whereas vaporizing top to bottom counteracts buoyancy separation. The vaporization chamber itself is designed to provide turbulent and chaotic flow, ensuring nothing but a truly homogeneous sample can exit the vaporizer. Nothing has been left to chance, with every aspect being meticulously and methodically resolved. The system is provided without dead spaces in the sample pathway, is highly compact, lightweight, energy and LNG efficient. Our LNG sampling solution requires no vacuum insulation, no sacrificial cooling flow, and preserves subcooling. Our technology is protected by a number of patents. Information on this can be found by following the address displayed at the end of this video.